Good morning. I'm Mr Okeyo. I'm going to take you in QT and Business Mathematics, a class which is combined. So we are going to look at a subtopic of transport, which is in a wider topic of linear programming. So linear programming is subdivided into different subtopics. So we are going to start with the transport. And under transport, there are also it's also called transport and assignment, because we have to assign those demand and supply in a table that will be given. So as you see in the whiteboard, this linear programming, transportation and assignment. We have different methods of calculating transportation and assignment, and today we want to look at a topic which is called Vogel approximation method. There are other methods, but this one is the first one that we're going to look at, Vogel approximation method. Now we have been given an example here. This is an example in a question, that in this question we have three factories. We have factory A, B and C. These three factories, they have their capacities. Factory A have a capacity of 45. Factory B have a capacity of 15. Factory C have a capacity of 40. Now that means that they can accommodate units which is less than this. These are the maximum. So like A can accommodate a maximum of 45, but not more than 45. Now, in this factory, they have what called warehouses. And warehouses, we have warehouse 1, 2, and 3, because after manufacturing, they have to store them somewhere. Now, what's the capacity or the demand of these warehouses? For warehouse 1, it is 25. Warehouse 2, it is 55. Warehouse 3, it is 20. Then, these are the movement that you have to give in that table. This table, we have this one are from factory. They are from factory going to warehouses. So we have factory A, B, and C. Then we have warehouse 1, 2, and 3. Now we have been asked the question that find the optimal transportation schedule and minimum cost. Now, can I have? So this is the table that you are given. Now you have to put those capacities. For example, warehouse 1 here was 25. So we are going to put 25 here. Warehouse 2 was 55 there. Warehouse 3 was 20, so 20 there. If you come to the factories, factory A have a capacity of 45, so you put 45 there. Factory B of 15, factory C of 40. Now, if you look at the capacity, if you add this 25 plus 55 plus 20, you will get 100. If you add 45, 15 plus 40 here, you will get 100. So those units are equal both vertically and horizontally. Now, we are using Vogel method. If you want to use Vogel method, you are going to add these numbers in the cubes. So for example, there we have 10 plus 7, that's 17, plus 8, that gives you 25. This one, 15 plus this one is 27. 27 plus 9 is 36. 7 plus this one, 8 is 15, plus this one is 27. Now, you choose the largest figure in these three. We have 25, we have 36, and we have 27. So the largest is 36. Now, and the number that we are going to allocate is 15. 15 we are going to locate in these 3 tubes. And we allocate it to the smallest unit. So in this unit we have 15, we have 15, 12 and 9. The smallest unit here is 9. So this 15 we are going to allocate it here. Then after that, choosing the largest, we go to the smallest. The smallest there is 25. And 25 capacity is 45. Now this 45 you have to distribute it in these 3 cubes. So first of all, you go to this column where we had 15. Now 15 down here is supposed to add to 20. Means that if you had 15, we remain with 5 so that we can get 20. So that 5 is going to be here. Now if you remove 5 from 45, you are going to remain with 40. That 40 you have to allocate to the smallest number, which is 7. So that 40 is going to be there. Then you are remaining with the column, the lower column, which is 40. Now 40, you are going to allocate to this 8, because here we had 40, but the capacity is 55, meaning that we are remaining with 15. Then 15 subtract from 40, you get 25. Because this column is full, this column is full, this column is the one which remains, so that 25 becomes there. Now after filling that table, now we have to calculate minimum cost. We're going to calculate minimum cost. Minimum cost. And how do we calculate minimum cost? These figures that we have inserted, we are going to multiply them with the numbers you are there previously. So for example, this one we had 7, so we are going to have 7 times 40. 7 times 40 is going to give us to 80. Then this one is 8 times 5, which is giving us 40. Then this one is 9 times 15. 15 times 9, 15 times 9 is, that's for 135. Give us 135. Then here we have 7 times 25. 25 times 7, that's 14, 15, 155. Then we had 8 times 15. 8 times 15, so 15 times 8, that's 04, 8, 120. Then we have, lastly, that's the last we have. So we have 7 times 14, 8 times 5, 9 times 15, 7 times 25, 8 times 15. Then you add all of them. If you add them, what do you get? This one is 0. That's 9, 13, 16, 21, 23. So 23, that's 3, 4, 5, 6, 630. Now 630 is going to be our minimum cost. So that's the how we are going to calculate transport schedule. So this is the transport schedule that we wanted, and then this one is the minimum cost of that transport and assignment. So that's one of the methods we are going to use to calculate transportation. So next time we will look at another method. Thank you.